Okay, welcome back. And we are going to start working on our lesson called Bar None, solving one-step addition equations. So we're only going to concentrate on addition for now. And we actually previewed this last week if you were done with your last assessment. So hopefully a lot of this is review. Page number M3107 is where we're going to start with our warm-up. And so we are going to determine the sum. So we are warming up and thinking about how we find different kinds of sums. So what we're looking at is reviewing how to add decimals, how to subtract decimals, how to add and subtract fractions. So I'm going to do a real quick review here. So remember, when we are adding or subtracting decimals, I would rewrite it and stack or line up the decimals. Okay, that way, if I line these decimals up, all I have to do is bring it down to the answer and I add like I normally would. Now, that keeps us adding the same place value to the same place value. So if I didn't have the decimals lined up, I might be adding ones to tens or hundredths to thousandths. Okay, so remember, this is our hundredths. This is the tenths. Those are not even whole numbers. And then these are our ones. Okay, so let's start adding. 7 plus 3 is 10. Carry the 1. 7 plus 6 is 13, plus the 1 that we carried would be 14. I have another 1 to carry. 8 plus 5 is 13, plus 1 more is 14. So there is our answer. 14 and 40 hundredths, or since it's a 0, we could just take that 0 off and call it 4/10. Okay, now we would do the same thing when we are subtracting. So I'm not going to actually subtract this. I am just going to line up the decimals and show you how we would write that. So boy, Mrs. Canupp didn't do a very good job of lining those up. Let me try that again. There we go. Now remember, it's subtraction. So you might have to borrow. Okay, but you would still just drop the decimal down and handle each place value on its own. Now, the thing that most of you do not like, we're going to work with fractions here. Now, when we add or subtract fractions, the bottom number or the denominator has to be the same number. So the first step is finding the least common multiple of 7 and 5. We did this before. Let's see. Probably going to be 35. Ooh, yep. Okay. So I'm going to take 3/7 and I'm going to change it into an equivalent fraction, which is what we've also been doing in intervention. And I think about this by saying, how do I go from 7 to 35? Well, that's 7 times 5. So I'm going to multiply the numerator or the top number by the same exact thing. So 3 times 5 is 15. So now I have 15 and 35 hundredths. Now I have to change 4/5. Okay, so I'm going to do that over here. 4/5 has to be something over 35. So I know 5 times 7 is 35. So I do the exact same math. 4 times 7 is 28. So now all of a sudden I am adding 28 35ths. We simply add straight across and our denominator stays exactly the same because that tells us the size of the piece. That tells us the one whole entire piece is cut into 35 smaller pieces. That's why when you're adding or subtracting, you have to have the same denominator because it tells you the size. Okay, let's see. 8 and 5 is going to be 13. So looks like I have 43 over 35. Now you guys can leave it just like that. But what I want you to at least start to recognize is that that is an improper fraction because the top number is bigger than the smaller number, which means we could simplify that and do some more math. Okay, but for today, I want to move on. Now, this one's slightly easier because 3 and 4, we can kind of see that, hopefully, you can see that the least common denominator would be 12. Okay, so if I think about how to go from 3 to 12, that would be times 4. So I'm going to take 20 times 4, uh, which would be 80. And then I go from 4 to 12, which would be times 3. So I'm going to take 15 times 3 is 45. And I have a little kitty back there making some noise if you hear something, or if I have to yell at her. Okay, so I just did that subtraction in my head. If you need to, you can write out here. Okay, now once again, we're going to leave it alone, but I want you to start realizing that since the top number is larger than the bottom, we would need to divide and simplify that. That's called an improper fraction. Okay, so now that's just warming up. Those are just skills that we should be familiar with. So where we're trying to get to is our algebraic equations. Target 1, we're going to solve one-step algebraic equations. Remember, equations have equal sign. So you're going to be working with lots of vocabulary words, okay, and we will get there. I have a group where you can rotate and make a vocabulary page, so this will be helpful. Okay, our learning goals on page M3107. We're going to reason about addition equations and we're going to take a look at bar models. Most importantly, to serve us in the future is going to be this inverse operations. So on page M3107, we have our vocabulary words that will be covered in this section. So we're going to go ahead and jump right in and understand that a bar model is rectangular bars to represent known and unknown quantities. Sometimes when we make models or draw pictures, it's easier for us to figure out a solution or at least understand where the solution came from. Now, right over here, I want you to realize that a solution to equation is the value for the variable. Remember, the variable is the letter. We don't know what it is until we solve, and it makes the equation true. Remember, equations have equals. Basically, we have two algebraic expressions or two expressions, and then they're separated by an equal sign. So let's take a look at the worked example. We are thinking about something, we're going to call it an x plus 10 equals 15. Now, they drew two rectangles. The first rectangle has our x plus 10, so it has exactly what's on one side of the equal sign. And then the other side has 15 because that's what's on the other side of the equal sign. They're the same exact size rectangle because that's what the equal sign means. It means both sides have to be equal to itself. Okay? Now, what they did next was they took the x plus 10 and they broke it into two smaller rectangles. So let's go yellow and this hot pink. So as you can see, the rectangles are two different sizes. One comes from the x and the other one comes from the 10. Now, what they're trying to get us to understand, and I'm going to color code to help you see, is they took the 15 and they broke it into the same size squares and rectangles to illustrate or show how to solve this. So we can see that I know that there's a 10 here. So if I come down and make one of my boxes 10 from my 15, then that helps me figure out what goes over here because total together, I have to equal 15. So we can see the missing number is 5, and that is what our x is. Okay, now that just shows a picture. Okay, let that sink in. So why is the number 15 decomposed into numeric expressions 5 and 10? Well, that's because, make sure you're writing this down on page M3110. That's because 10 is being added to x. So by decomposing or breaking down 15 into 5 plus 10, I can find the missing number. Okay, I'll let you write that down. You can pause it if you need to. We're going to take a look at one more model. So now we have x plus 10 equals 17. So you can see they have x plus 10, and they broke that into x and 10. Pretty simple, right? So that means they had to take the other side of the equal sign, which is 17, and we're going to break that into, remember, we want to use this number. We're going to break that into 10 and something. So I'm thinking about 17 and 10 and know that these two boxes together have to make 17. So I'm thinking about fact families.